What's a dual of a proposition? This is something you might encounter in discrete mathematics, dealing with propositional logic. Now, here we have the compound proposition S, which only consists of the sentential connectives and, or not. And the dual of S is sometimes denoted as S asterisk. Basically, what we're going to do is take the conjuncts, turn them into disjuncts. We'll take the disjuncts, turn them into conjuncts. Moreover, we'll take tautologies, turn them into contradictions, and contradictions into tautologies. For example, let's say we have something like parentheses, P and Q, close parentheses, or R. And this is our original proposition. We'll denote that as S. It is a compound or molecular proposition. Moreover, it only consists of the sentential connectives and, or not, so we're good to go. Let's take the dual, S asterisk. So we'll just flip the conjuncts to disjuncts, the disjuncts to conjuncts. Thus, parentheses, P or Q, close parentheses, and R. So we just moved from our conjunction to our disjunction, from our disjunction into our conjunction. For another example, let's say we have something like S as P or not B, or A or not C, and something that is necessarily false. So S asterisk would simply be parentheses, P and not B, close parentheses, and A, and parentheses, not C, or something that is true. So we move from our disjunction to our conjunction, from our disjunction to our conjunction, from our disjunction to our conjunction, from our conjunction to a disjunction, from something that's necessarily false, a contradiction, to something that's necessarily true, tautology. Or we might have something like this. Let's say P and something that's necessarily true. So S asterisk would just be P or something that is necessarily false. We move from a conjunction to a disjunction, from a tautology to a contradiction. We can think about properties. One property is simply that S asterisk is logically equivalent to S. It's analogous to double negation. So we have S, we flip things, we flip them back, so we're back at the original S. Moreover, notice, for example, that the equivalency laws I provided here, namely the commutative laws, the associative laws, the distributive laws, De Morgan's laws, the absorption laws, the negation laws, the identity laws, and domination laws, come in pairs. In fact, if you look closely, they're duals of each other, each and every one of them. So for example, the commutative law. There's that, and there's this. They're duals. We can ask questions such as, is it possible that S is logically equivalent to its dual? And if you think about it, the answer is yes, it is possible. Notice the absorption law. So let's say that, so taking that absorption law, S, we'll say that is P and parentheses P or Q. So its dual would be P or parentheses P and Q. But notice the first statement is identical to P, or logically equivalent to P, I should say. And the second statement is also logically equivalent to P. So therefore this statement and this statement must be logically equivalent, so we have a situation where S is logically equivalent to S asterisk. So this is a basic introduction to duals. I hope it's been helpful. Thanks for watching.